In this next example, we want to factor and find all of the zeros, that is real and complex, of the polynomial that we're given here. So we're going to go through all of the steps that we've done in the previous chapters, and we are going to hopefully find 4 zeros. So let's start with Descartes' rule of signs. These are all positive, and that one's negative, so there's one sign change there, meaning we have 1 positive 0. Replacing x with a negative x and changing the signs of all of the odd exponents, we end up with this. And looking for sign changes, we go positive to negative to positive to negative, and then that stays negative. So there are 3 or 1 negative real zeros. From there, we have factors of 18 are 1 and 18, 2 and 9, 3 and 6. And for Q, we have factors of 3. Factors of 3 are 1 and 3. So our possibilities for P over Q, the rational zeros, are 1 over 1, 2 over 1, 3 over 1, 6 over 1, 9 over 1, 18 over 1, 1 over 3, 2 over 3, 3 over 3, 6 over 3, 9 over 3, and 18 over 3. Some of these are repeats. For example, 3 over 3 is 1. We already have that. 6 over 3 is 2. We already have that. 9 over 3 is 3. We have that. And 18 over 3 is 6. We have that as well. So we have plus or minus. Let's see, there's 1, 2, 3, 4, 5, 6, 7, 8. So double that. 16 possibilities for those rational zeros. We don't really want to have to check all of those. So what we can do is we can get a sketch of what's happening using our graphing calculator if we wish. And if we do that, the hint is to try -2 and positive 1/3. That is, the graph ends up crossing at -2, and it looks like perhaps a positive 1/3. Graph does something like this, something like that. So let's try -2. We need to look back at our polynomial and decide whether or not we have any missing terms. Doesn't look like there are any missing terms. Then take care of those coefficients, 3, 5, 25, 45, -18. 3, 5, 25, 45, -18. And do the synthetic division. 3 comes down. 3 times -2 is -6. -6 and 5 add up to 1. -1 times -2 is a positive 2. Adding those gives 27. Multiplying by -2 gives -54. Subtracting there, or adding there, gives 9. 9 times 2 is 18. 18 minus 18 is 0. Great. So what that means is that x equals -2 is a 0, or x plus 2 is a factor. So what we're left with is 3x cubed minus 1x squared plus 27x minus 9. We can either try factor by grouping, or we can try our other hint, which was a 1/3. Let's try the 1/3. Copying down what's left and doing synthetic division. Got our 3. 3 times 1/3 is 1. 1 minus 1 is 0. 0 times 1/3 is 0. 0 plus 27 is 27. 1/3 times 27 is 9. 9 minus 9 is 0. So x equals 1/3 is a 0, or x minus 1/3 is a factor. So what's left? What's left is 3x squared plus 27. When we have 3x squared plus 27, we can just solve this like we're used to doing. This is something we can start off. I want to point out that there's a common factor of 3, so we would like to factor out that 3. So what I want to point out is there is a factor of 3. That's important. So if I have x squared plus 9 equals 0, and I want to solve this, I get x squared equals -9. Taking the square root of both sides gives us plus or minus the square root of -9, and we know that is plus or minus 3i. So it looks like we have two imaginary roots. So if these are two zeros, imaginary zeros, then one way of writing it is x equals 3i is a 0, so x minus 3i is a factor. X equals -3i is a 0, so x plus 3i is a factor. If we look back at all of the factors that we found a factor of x plus 2, x minus 1/3, a 3, x minus 3i, and x plus 3i. So our polynomial f of x factors to 3 times x plus 2, x minus 1/3, x minus 3i, x plus 3i. So there's our polynomial factored. If the question was find the zeros, then we could just list the zeros: -2, +1/3, +3i, -3i.